Now let's talk about quarks. If we rightly go back to neutrons and protons, and protons, the neutron, which is basically a hadron, it has a magnetic moment, and magnetic moment of neutron is it's minus 1.931 EH cross by 2 MP. And we have the magnetic moment of proton, which is nearly 2.793 times EH cross by 2 MP. And since neutron has a magnetic moment and proton has magnetic moment, it has led physicists to a straightforward conclusion that hadrons are not hadrons, or not they are not the really elementary particles. But they themselves are made up of some small charged particles. And if I have to draw it in some other way, these hadrons have substructures. And the magnetic moment that we have, the magnetic moment is basically the result of the orbital motion of a charged particle. So this magnetic moment should be due to this orbital motion of the charged particles. And at the same time, this neutron is a neutral charged particle. It doesn't have any charge. It has a zero charge. So it must not have any magnetic moment if it does not carry a charge with it. But what we see is the definite value of magnetic moment of neutron, and it is associated with this neutral particle neutron, and this led to an idea that this neutron is made of small charged particles, small charged particles. And the charges of these particles, they add up to zero. So if you have a charge A, charge B, and charge C of the particles that are inside the neutron, that builds a neutron, their sum goes to zero. Now, this orbital motion of these charged particles within the neutron, if I assume this to be a neutron, it gives rise to the magnetic moment that has been calculated experimentally over here. And some state of explanations suggest that all hadrons have substructures. And it was probably in 1964 when this 1964 this Gell-Mann and G. Zweig, they independently proposed that all strongly interacting particles are made up of the triplet, unitary triplet, comprising three particles, and these three particles are quarks. And the three types of quark, they are basically the building blocks of mesons and and baryons. Now, these three quarks are known as, the first one is up quark and symbolized as U. Then the next one is down quark and it's symbolized by small d. And the third one is strange quark, strange, and it is symbolized as S. And this U and D, the up quark and down quark, they belong to an isospin doublet with strangeness S equal to 0. Now the third quark that we have here, S, it belongs to an isospin singlet. So they belong to the doublet and it belongs to the isospin singlet, and is a strange particle with S equal to -1. Now all the three quarks have the spin of 1 by 2 h bar, and hence we can code them, we can frame them in the group of fermions. These quarks have fractional charges and fractional baryon numbers. And the three quarks that we have, up, down, and strange, they have their antiparticles. The antiparticle of up is U bar, the antiparticle is down is D bar, and the antiparticle of S is S bar. So all the three quarks have these antiparticles. And let us put down some of the important properties of these quarks in some tabular form. Here we would like to name them, then let's go with their symbols, then let's go with the charge, then let's go with their spin, strangeness, and the baryon number. Now, so here I have the name of the quark, then I will have the symbol, then I will have the charge in terms of E, and then we'll have the spin in terms of H bar, then strangeness in terms of S, and the baryon number in terms of B. Now, for the up quark, what we have, for the up, the symbol is U, and it has a charge of +2 by 3, and it has a spin of half, 1 by 2 h bar, and it has a strangeness of 0, and its baryon number is +1 by 3. Okay, this is our up quark. Then we have the down quark. And for down, what we have, the symbol is D, and its charge is -1 by 3, and it has a spin of +half of h bar. It has 0 strangeness number, and its baryon number is +1 by 3. And then we have the third one, that is strange, and its symbol is S, and its charge is -1 by 3. It has a spin of half h bar, and it has a strangeness of -1, and its baryon number is 1 by 3. Okay, so this is how I have tried to classify these three quarks in terms of their symbol, charge, spin, strangeness, and baryon number. Now, moving on, it was probably in 1974 a new meson, which is symbolized as psi, was discovered with a rest mass, its rest mass energy of the order of 3.1 giga electron volts. And this meson, this is probably a meson, and this meson was expected to decay through strong interactions in a characteristic time of the order of 10 to the power of -23 seconds. But but it decays through electromagnetic interaction. And how it decays into a positron and an electron. So this discrepancy, that what was predicted and what was observed, was resolved by assuming that uh, this psi meson that we have was made up of a new quark. It was made up of a new quark called as charm, and it's charm quark, and its anti-quark. So its symbol is C, and its anti-quark. The anti-quark of this charm is C bar. Now the charge on this charm quark is it's probably 2/3. It's plus 2/3. And the charm quantum assigned here, this quantum assigned to this C quark, is that this C is +1, and for the quark, and this its quantum number is -1 for the anti-quark. And then so we have another quark here, and then another meson was what's called as epsilon. It's Y epsilon, and with the rest mass energy of the order of 9.5 giga electron volts. This particle was discovered, and it decays through electromagnetic interaction into an electron and a positron. And this led to a new quark. We call this as bottom quark. I mean bottom, BOTOM, bottom quark, with the quantum number bottomness B equal to +1. And the charge on the bottom, or sometimes called beauty quark, its charge is -1/3e. The anti-quark of this bottom that we have, B bar, its anti-quark, and the sixth quark that's top, T. It was discovered probably in 1994 in proton and antiproton collisions, and probably in Fermi lab, and its energy was found to be of the order of 174.2 giga electron volts. Now this top is also called as truth. Truth quark, it has an associated property of topness, with the quantum number T equals to +1.